Hello everyone and welcome to another lesson on Chapter 6. Today we are on 6.8 notes. This is day 1 of those notes. We're having a couple days of quadratic word problems. And I know that you guys all love word problems so much. You gotta love them, right? We often don't like word problems too much, but if you think about it, that's what math is for. It's to have a problem in real life and be able to solve that problem. And so when we talk about quadratic word problems, we might think that we don't see those too often in real life. If you are interested in a career of physics, I would say that you're going to use quadratic equations quite often. If you just kind of think about it for a second, let's just think about sports. Sports, we see parabolas all the time. If you're in football, the next thing that you do on a fourth down play is oftentimes you have to punt it. When you punt it, what shape does that look like? That is the trail of the ball, the path of the ball. And doesn't that look like a parabola? If you think about a basketball player shooting a free throw, when he shoots a free throw or she shoots a free throw, doesn't it look something like that? I would say so. If you're a tennis player, doesn't the rally of the ball go something like this? Back and forth, right? Those are just a bunch of parabolas. If you were to think about being stranded in the middle of an ocean on a boat, sometimes you have to send a flare. What is the route that flare takes? It sparks, it hopefully gathers a plane. All I'm seeing up here is a bunch of parabolas, right? So we see parabolas all the time, and we need to understand them and know how they work. So here's another one. A carnival game involves striking a lever that forces a weight up a tube. If the weight reaches 20 feet to ring the bell, the contestant wins the prize. So here's the situation. You guys all seen at one of those carnival games, this big, huge, muscular man, right, that has these big, old, huge, broad shoulders. He wants to win his girlfriend a prize or something like that, one of those big, huge, stuffed bunnies. I don't know, something like that, right? But in order to do that, he has to take this big, huge hammer, strike this platform. This weight in that platform goes up this tube, bing, it hits the bell, he wins a prize. Or it gets really close, but it doesn't quite hit it, sorry, he gets no prize. So that's the deal here. The equation for this weight in the tube is this equation. It gives the height of the weight if the initial velocity is 32 feet per second. Graph the equation and then answer the questions. So here's our quadratic equation. So the first thing we have to do is we have to find the axis of symmetry. So the axis of symmetry, as we know from previous lessons, is it's a negative b over 2a. So x equals a negative 32, because that is my b value. My b value is 32, but it's a negative b, so a negative 32 over 2 times a, which is a negative 16. So a negative 32 divided by 2 times a negative 16 is a negative 32. So a negative 32 divided by a negative 32 is a positive 1. So my axis of symmetry is x equals 1. All right, moving on. We now have to find the vertex. You find the vertex by substituting in the axis of symmetry. So my equation for h equals a negative 16 times t squared, and t, I guess, instead of x, we could say t, is 1 squared plus 32 multiplied by 1 plus 3. So our vertex, 1 squared is 1, and 1 times a negative 16 is a negative 16. 32 times 1 is a positive 32, and then plus 3. So if we were to do the math here, a negative 16 plus 32 is a positive 16, and then 16 plus 3 is a positive 19. So my vertex is an xy ordered pair. That xy ordered pair is 1 and 19. There is my vertex. So now, class, let's think about this for a second. Our equation right here has an a value of a negative 16. If the a value is negative, does the parabola look like this or does it look like this? It opens down, correct? So right there. Now what did you find by this 119 here? You found the vertex, which the vertex is always a maximum value or a minimum value, all depending if your parabola goes up or down. And because it goes down, you found that maximum point. It is 119. So let's put that on our graph. 119. So these are going in increments of 1, but the y-axis goes in increments of 4. So at 119, we are right about there. All right, now you see that this chart is right here. With this chart right here, we always plot 2 points to the right of our vertex and 2 points to the left of our vertex. So if we found 1 point to be 119, let's find when x is 0 and a negative 1, because that would be 2 to the left of my vertex. And let's find what happens when x is 2 and 3, because that would be 2 points to the right of my vertex. So you guys could pause the video. Why don't you solve for y, substituting x into this equation? So why don't you guys do that really quick? All right, so our equation was a negative 16 t squared plus 32t plus 3. So then when you put in a negative 1, a negative 16 times a negative 1 squared plus 32 times a negative 1 plus 3. When you put in a negative 1, you got a y value of a negative 45. So now when you put in a 0, a negative 16 times 0 squared plus 32 times 0 plus 3, you got a value of 3. When you put in 2, a negative 16 times 2 squared plus 32 times 2 plus 3, you should have got a value of 3 again. And then when you put in 3, a negative 16 times 3 squared plus 32 times 3 plus 3, you should have got a value of a negative 45. Now hopefully you're seeing a pattern here. These two are both 45. These two are both 3. And hopefully that makes sense because parabolas are always symmetrical. So hopefully this isn't a surprise to you. It makes sense. So let's plot these other 4 points. At 0, 3 we have a point. So right about there. And at a negative 1, negative 45. So way down here. Right about there. And then we also have 2 points to the right of my vertex at 2, 3. And at 3, negative 45. Alrighty, I'm going to connect these dots in the form of a parabola. Alright, so hopefully your parabola looks something like that. So, this is the route that that weight takes after it's been struck with that hammer. It gets hit with the hammer, it goes up and up and up until it finally comes back down again, and so on and so forth. So that's the route that we're taking. Now let's answer the questions. What is the maximum height of the object? Let's talk about these letters for a second, class. H, that stands for height. And T, that stands for time. And in this case, it's time in seconds, because this initial velocity is 32 feet per second. So our time parameter is in seconds. So if we look at this, what is the maximum height? What we're looking for is what is the vertex, because our vertex is a maximum point. So how high is this value right here? It is the same as our vertex. Our vertex is at 119. or my y coordinate is 19. The maximum height is 19, and in this case we label it as feet. It's 19 feet. And if you want to put in parentheses, why do we know this? It's the y coordinate of the vertex. At what time does the object reach the maximum height? T is our time in seconds. So here's 0 seconds, 1 seconds, 2 seconds, 3 seconds, 4 seconds. When it reaches this maximum height of 19 feet, 1 second has passed. That is the x-coordinate of my vertex. So 1 second. And once again, if you want to put in parentheses, how do we find that? It's the x-coordinate of our vertex. What height did the object get released from? And how can you tell that? So basically, class, this weight is sitting on top of a pedestal. Is it sitting on the ground? Or is it sitting on maybe a platform that is above the ground? What height did the object get released from? When time is 0 seconds, okay, so no time had passed by at 0 seconds, how high is this? When t, right here, is 0, what is my height? Well, when we substituted in 0, when x was 0, what was the height? Our height was 3. So 3 feet off the ground. How long does it take the object, or wait, sorry, up to this one. What height did the object get released from? 3 feet. How can you tell? That is the height when t equals 0. So think of it this way, class. Our x-axis, for these negative numbers, the red really doesn't matter, because that never actually happened. It started 3 feet off the ground. Okay, so this circle that I'm making right here, it started at 3 feet off the ground, and boom, this big, strong guy, he struck that with the hammer. And the weight goes up and up and up, and now it starts going down again. So right here is when time is 0, and that height is 3 feet. How long does it take the object to return to its initial position? How can you tell? Well, its initial position is 3 feet. So how long does it take for it to get back to 3 feet again? It's 3 feet right here, which is right here, and it's also 3 feet right here, or 3 feet right there. And it's at 3 feet when my time, or my x variable, is 2. So here is 0 seconds. 1 second is at its maximum. 2 seconds, it's right back at 3 feet again. 2 seconds, it's right back at 3 feet again. So how long does it take the object to return to its initial position? It takes 2 seconds. How can you tell? That's the time it returns to 3 feet again. All right, and then, oh, not last question, second to last one. If the object were to keep traveling, at approximately what time would it hit the ground? And how can you tell that? So if we look up here, class, it's on a platform right here. So it gets struck, it goes up, it comes back down, and it's going to land right back on top of this platform again 2 seconds later. However, if this platform wasn't here, this 3 foot tall platform, it would then fall an extra 3 feet right here. And it says approximately, so we're rounding, we could actually find this out by using the quadratic formula or by completing the square and doing a whole bunch of work, but we're just going to say approximately what time would it hit the ground. It would hit the ground in between 2 and 3 seconds. Probably closer to 2, but we'll just say between 2 and 3 seconds. Between 2 and 3 seconds. How can we tell this? It is when my graph hits the x-axis again. So I want you to write, that is where the graph crosses the x-axis. Maybe the function. That is where the function crosses the x-axis. Another way you could say that is where h is 0. When my height is 0, that is, I'm getting a lot of different colors up here. When my height is 0, that is right there where that blue dot is. So when my height is 0, it is in between 2 and 3 seconds. So last thing, this big, huge, muscular guy who wants to win a nice, big stuffed animal, bunny, whatever, for his girlfriend, will the player win the prize? The highest that weight goes is 19 feet. How high does it need to go to get the prize? It needs to go 20 feet. So he came up a foot short. So, sorry, buddy. Hit the weight room, come back again next year. Because, no. The height to win is 20 feet. The weight only went 19 feet. So that's how you do this one. Let me know if there's any questions on this one. I can maybe explain through maybe some more hand motions or drawing pictures and stuff like that too. It's a little bit hard to explain it with just a smartboard. But if you do have any questions, please feel free to let me know.